In this episode of Single Variable Madness, we have x to the fifth equaling 1, and x does not equal 1 in this equation, and we want to find x to the fourth plus x cubed plus x squared plus x to the first plus 1. So, how do we start with this? Well, first thing we can see is that x to the fourth plus x cubed plus x squared plus x to the first plus 1, this looks like a series of some sort. And after further inspection, it looks like a geometric series, starting from 1. To get to the next term, you multiply by x, then you get x to the first, multiply by x to get x squared, multiply by x to get x cubed, multiply by x to get x to the fourth. So this is a geometric series. So therefore, maybe we can plug in this equation into the geometric series equation. But first, let's derive that geometric series equation. Let's say we have a geometric series S, and that S equals sum of first term A plus A times the common ratio R, plus A times R squared, because again, R gets multiplied to the next term, plus AR cubed, plus all the way to A times R to the power of n minus 1. So let's just say that's what this geometric series looks like. Well, let's multiply this whole equation by R, the left hand and the right hand side. You get S times R equals A times R plus A times R squared plus A times R cubed plus A times R to the fourth all the way to A times R to the n. So again, you just multiplied this whole equation by R to get this equation on this other line. Now let's subtract this second equation from this first equation. From doing so, you get S minus S times R. Let's factor out an S to get S times 1 minus R equaling, well, the A still stays the same, but this A times R gets subtracted by this A times R, so these two cancel. This A times R squared gets subtracted by this A times R squared, so these two cancel. Same with A times R cubed, A times R to the fourth, all the way to A times R to the n minus 1. That gets subtracted by the A times R to the power of n minus 1 in the second equation, and therefore all of those terms cancel out, and finally you're left with this minus A times R to the n. Minus A times R to the n. Let's factor out an A on that right hand side to get, well, on the left hand side still S times 1 minus R equaling, but this time it's A times 1 minus R to the n. Dividing both sides by 1 minus R gets us S equals A times 1 minus R to the n, all divided by 1 minus R. Cool, so now we just have to plug in this equation into here and we should get an answer. Well, what's our first term? That's just 1. As we can see, our first term here is 1. Then we take 1 minus R, our common ratio is x. X is getting multiplied by each term. N, the number of terms in our series, is 1, 2, 3, 4, 5. 5. And then divided by 1 minus R, which we already said was x. From here, however, we can see that we already know the value of x to the fifth. We said x to the fifth was equal to 1. So we have 1 times 1 minus x to the fifth is 1. All divided by 1 minus x. We still don't know what x is in this case. But the numerator, well, 1 minus 1 is 0. 0 times 1 is 0 times 1 divided by 1 minus x, and that's equal to 0. As we can see, we didn't actually need the value of x itself in this equation. We found that the actual value of this geometric series, x to the fourth plus x cubed plus x squared plus x to the first plus 1, is just equal to 0. And we are done.